Hello, my name is Ravi Davuluri. I'm an applications engineer in core switching group at Broadcom. Today, I would like to show on how to get started with NPL. Let's take a look at nplang.org. nplang.org is hosted to enable open community on network programming language. NPL specification can be downloaded from here. This also gives us a pointer to GitHub where NPL compiler suite, sample examples and applications were hosted. NPL GitHub has three major repositories: NPL tutorials, NPL example applications, and NPL specification. NPL tutorials repository has details on how to set up your own working environment. To accelerate users' hands-on experience, we have prepared a complete test environment in virtual machine. Instructions on how to download virtual appliance file and also virtual box to host virtual appliance file are shared in this GitHub page. This repository also contains NPL tidbits. NPL tidbits are designed to be simple and comprehensive to have users get hands-on experience on NPL constructs, which are fundamental components of NPL language. Each example in NPL tidbits is designed to focus on specific constructs. Second repository in NPL and GitHub page is NPL example applications, where we have provided a couple of NPL applications to demonstrate layer 2 and layer 3 functionality on an Ethernet switch using NPL language constructs. Examples helps users understand how NPL program can be written to parse and forward packets based on match action resolutions. Test environment discussed before will help users to get hands-on experience on the compilation and verification workflow using NPL language compiler and behavioral model. Now let's see how to set up a test environment using links provided in NPL tutorials GitHub page. Step 1 is to download a virtual box. Step 2 is to download a virtual appliance file. Once you download the virtual appliance file, you can import the virtual by having an import appliance option here, and then select the OVA file that was being downloaded. Once you import, you can turn on the virtual machine by clicking the start button, which will prompt you for a password. The password here is NPL, all in lower cases. Let's take a quick look at directory structure in the test environment. Both NPL tidbits and sample examples are placed in the examples directory under NPL at this path. Let's take a look at a bus construct example and its folder structure. Each example consists of 4 directories. The NPL folder will have a main NPL program. BM test folder consists of packets that should be used to test the program, and also a special function that's needed for NPL program, and a make file for compiling NPL program, and a README file. Let's take a look at README file. This file contains a description of the example, contents of the example explaining the location of the main NPL program and its helper code, BM test directory, and where to find the test packet, table configurations that's been used to verify the NPL program, and also a detailed steps on how to compile and run the program. It also has details on what to expect when you verify the NPL program using packets. Let us take strength resolution construct example to compile and test using working environment. In NPL program, multiple tables may be looked up in parallel. When multiple tables assign the same object as an action, a mechanism is needed to resolve the conflict and derive the final value to use. NPL uses a strength-based mechanism for such resolution when a numerical comparison is sufficient to decide the winning object. Let's take a look at the NPL example that was given in this working environment to understand how the strength resolution works. Every example that we have written, we have added a description of the program as a header for users to understand the purpose of the example. We also added a topology diagram along with the verification methods used to verify the NPL program. This example illustrates strength-based mechanism to decide a winning object of cost value assignment when multiple tables can assign cost value. In this NPL program, there are 3 sources for cost assignment. One being the local bus, which is carrying the default cost assignment. The second one is priority cost mapping table for tagged packets. DSCP cost mapping table for IPv4 packets. Local bus provides fixed strength index as default strength index. Strength indexes are obtained by lookup results of priority cost mapping table and DSCP cost mapping table. Each entries of these tables can assign different values of strength index dynamically as a runtime configuration. Strength resolve construct resolves the winning object and output the final cost value to the local bus. The verification involves 4 key steps. First step being we have to compile the NPL program using NLC, which is also called as NPL language compiler, and the BMZ. The second step being we need to run the behavioral model generated from the NPL program. And the third step being we need to populate the logical tables of behavioral model using BMCLI. BMCLI is an interface to populate tables runtime. So this particular file that is under the BM test is pre-crafted with the logical tables that needs to be configured at runtime. The fourth step being we need to craft and send packets to behavioral model. Every example that we have written has a test packet that we have used to verify the NPL program. Users can choose to use the same, or depends upon the modifications that were done in the NPL, they can actually modify this test packet. So let's see step-by-step process involved to compile and execute an example program. First, we need to get into a bash. The command for that is sudo bash. And the password for this is NPL, all in lower cases. Once we're done with that, let's do a cd into ncs 1.3.3 rc4. And we need to source the setup script that was placed under bin setup.sh. We need to export the environment variables as needed. These are documented in the GitHub and also the README files under the examples. And then we move into the strength underscore costs example that we have just reviewed previously. Now, let's compile this strength underscore cost NPL program using the NLC. This step will help resolve if there are any syntax and semantic issues with NPL program. The command to do the NLC compilation is make fe underscore npl sim. So we don't see any errors, which means that the program that was written is correct in terms of syntax and semantics. Now let's build a behavioral model to verify the NPL program compiled in previous step. To do that, the command is make npl sim underscore comp. So the behavioral model has been built now. Now let's bring the NPL simulated environment to populate tables and send packets. The command to do so is make npl sim underscore run. This command brings us two XTerm videos. One with the name of B model, which is basically gives a console log for the behavioral model. And the other one with name being BMCLI. At this point, we can populate logical tables with runtime entries for match action from BMCLI window. As discussed before, all examples comes with pre-crafted example table entries. Users can choose to change it as required. The command to load the table configurations that were pre-crafted is rcload. The command is like rcload with the exact location of the table configurations that were pre-crafted. Now let's inject the pre-crafted packet using our original console window where we invoked the NPL sim. As discussed before, we provide a pre-crafted packets as well in this environment, which were located at BM test coordinate. And the command to invoke this packet is python space the location of the test packet. Now we will see packets transmitted and received on the same console. Also in B model XTerm window, you can see detailed logs on various table hits and the strength resolution based on packets received and tables populated. I hope this video enables you to try the rest of the examples at your convenience. For feedback and questions, please email us at npl-feedback.pdl@broadcom.com.